Namaste, welcome to this video. So this video is going to be on calculating the power of the signal x of t is equal to c cos omega naught t plus theta. So not only that, calculating the power, but what is the main observation that one can draw from this question. So let us go to the solution now. Solution. So we know the average power. So in general, it is going to be limit t tends to infinity. So average power, right? Time average power. So this is minus t by 2 plus t by 2. So mod x of t squared into dt. So this is true in general, right? But if the signal x of t is real, if the signal x of t is real, then what we can do is we can remove this mod. Okay, so the point here is this formula, whatever the formula we have written here, so this formula is applicable for any signal. In general, true. In general, so true for any signal. So signal can be complex, right? But if it is a real, then what we can do, we can remove this mod. So therefore, with this, so let us go to the next page. So for real signals, okay, so the average power is going to be, so limit t tends to infinity 1 by t, this is for one time period, okay, this is x square of t into dt, right? So just let us substitute for x of t. So limit t tends to infinity 1 by t minus t by 2 plus t by 2. So what is x of t from the previous page? So it is c cos omega naught t plus theta, right? If you square this is going to be c squared cos squared omega naught t plus theta into dt. So in order to solve this, we need one identity, that is cos 2 theta from our trigonometry background. So this is going to be 2 cos squared theta minus 1. So using this identity, so one can solve this. So what is this now? Cos squared theta from here. So cos squared theta is going to be 1 plus cos 2 theta by 2. Okay, so let us use this identity here, so in order to solve this average. So go to this is going to be limit t tends to infinity, so 1 by t minus t by 2 plus t by 2. Okay, so c squared, what about this cos square term? This is going to be 1 plus cos 2 omega naught t plus theta by 2 into dt, correct? So let us split this into two integrals. So limit t tends to infinity 1 by t, okay, so this can be split into two integrals. The first integral is this minus t by 2 plus t by 2 c square by 2 into dt is one integral. The second integral is minus t by 2 plus t by 2, this is going to be c square by 2 cos 2 omega naught t plus theta into dt, correct? So these are the two integrals. So now by inspection one can say, so this particular term, the second term, is going to be 0, because the area of sinusoidal signals for one time period is going to be 0. So therefore with that observation now, so the final answer is going to be, so limit t tends to infinity 1 by t, so what is this? C squared by 2 is constant, and the integration for this is going to be, so t over the limits minus t by 2 plus t by 2. So substitute the limits now. So if you substitute the limits, so this will lead to t tends to infinity 1 by t c squared by 2, this is going to be capital T, correct? So t will gets cancelled, so the overall final answer is c squared by 2. So this is the power we got for this particular question. So let us go to the next page. So therefore, for x of t is equal to c cos omega naught t plus theta is going to have the average power c square by 2 watts. Right? So what is the comment here? What is the main observation? The observation or comment is that so power is independent. So average power is independent of frequency omega naught and phase. Right? So that is the main important observation from this particular question. So let us take an example. So go to the next page. If let us say x of t is 2 cos 2t plus 30 degrees. So what is the average value? Average power? This is going to be simply 2 square by 2, which is going to be 2 watts. Right? So therefore, this is independent of frequency and phase. I hope you understood this. So let us stop the video here. So when we meet next time, we'll come up with a new question. So till then, take care. Namaste.